Thanks for joining. I am Ryan Gutwein. I'm with Ignite Assurance Platform. I'm a director. Just high level, we are a governance, risk management, and compliance platform. Can everyone hear me? Is that better? All right. All right. Ryan Gutwein, I'm with Ignite Assurance Platform. I'm one of the directors. This talk will be about operationalizing Kubernetes within DoD and really how we defeat some of these bottlenecks of bringing emerging technology into the DoD and other regulated environments. So again, Ryan Gutwein, come from an Air Force background. So I was in from 2005 to 2014, deployed a lot to the Middle East, and used a lot of a lot of technology that wasn't really modernized yet. A lot of just traditional security, laying down fiber, configuring layer 2, layer 3 switches, just a lot of traditional security stuff. So I consider myself like an old school information assurance guy. Have done a lot of operational security stuff within the DoD. Have also done private sector for large financial services companies like Equifax, TransUnion. So we have a lot of experience, about 12 years of experience in doing this work for large companies, and really have started modernizing over the last 3 to 4 years, containerizing our own application, deploying it as Helm charts, and really just kind of shifting left from compliance, because compliance has traditionally been just, a paperwork kind of thing. And so we're really putting this into action. So this is the agenda, high level. We'll go over system authorization, just giving you some context into the DoD, how they secure, how they deploy their systems and applications. Is it optimal? Is it the right way? And then we'll get into how the DoD has started to enable some of this technology like Kubernetes. We'll get into some of the software factories that are being implemented within the DoD, Platform One being kind of the main driver there. And then we'll get into some of the component aggregation, how we're automating this work by looking at the entire stack and really executing on compliance as code initiatives. And then I'll get into a basic demonstration of the platform, how we're bringing in, how we're automating this stuff, and also Iron Bank, which is the DoD container hardening repo. We have a cooperative R&D agreement with the 16th Air Force Cyber, so we're programmatically bringing in this data into our own platform. You want to see the problem? If you have a month, we'll go through all these boxes. So this is the Integrated Defense Acquisition Technology and Logistics Lifecycle Management Framework. I mean, this is one of many bottlenecks within the DoD of bringing emerging technology in. So yeah, obviously this is not working. The DoD is currently in the middle of modifying more of an agile acquisition framework. Again, just kind of giving you some context. This is the NIST 800-37, the risk management framework, and it's a very nuanced process, meaning it's not able to keep up with the pace of technology. It's very nuanced, as you can see. So this process comes from NIST 800-37, and a lot of the business logic that you see here comes from NIST. And so we've kind of baked all this stuff into the platform. So a lot of innovations going on within the DoD. There's probably about, approximately 20 software factories. Again, all spearheaded by Platform One, but there's still a lot of bottlenecks within, accrediting and deploying software within the DoD. Are we accrediting a process? Are we accrediting a continuous state? That's what we need to figure out within the DoD. That's what they're still trying to figure out within all these different mission owners. We have a lot of great technology that is trying to streamline the accreditation process by having mission owners kind of onboard Platform One, and they have all these different kinds of services, Iron Bank being one of them. We'll get into Big Bang Platform, things like that. But I, again, just kind of want to give you some context. Platform is an overloaded term, and so This is kind of the stack for the DoD. So bottom layer, you see infrastructure layer, SC2S, C2S, fences. Those are all secret cloud environments, and they all sit on top of AWS, Azure. And then platform layer, you have your CNCF, your compliant Kubernetes stacks, and then you have your CI/CD, your continuous delivery, your DevSecOps, and that's going to be your Big Bang platform. And I'll get into Big Bang here in a second. Service mesh, they use Istio Envoy proxy for service mesh, and then monitoring the service mesh via Kyali, Grafana, Prometheus, Alert Manager, Jaeger, all those observability tools. And then application layer, we want to focus on the mission apps, and so that the developers are just continuously delivering capabilities, so they can focus on apps, putting more burden on the platform. And this is another visual of kind of how we're layering the authorization process within the DoD. You can see bottom layer infrastructure. There might be an agency that's doing, account management. They're provisioning accounts via Active Directory or whatever. And then really platform layer, again, where a lot of the burden's put on them. You can see, DevSecOps pipelines, that could be like 5 or 6 different tools, right? Logging, monitoring, that could be like 5 or 6 different tools. And so, the container registry, dependency management, secrets management. So all these burdens are put on platform team, putting less burden on the containers and the minor application teams. Again, bottom there, the controls, the requirements, they come from NIST 800-53. CNSSI is regarding national security systems. 1253, they just used the 853 control set. FIPS 199 is the Federal Information Processing Standard. That helps with categorization. And categorization is a whole other workshop when we categorize the impact of systems and applications that are operating within the DoD information environment. There was an SBOM talk earlier. I believe it was Show and Tell, John Osborne with Chain Guard, and Mark Borstein with Tremolo did a pretty good presentation on SBOMs. We don't produce SBOMs. Software billing and materials are kind of lower level on the hierarchy of software, but it's something that we have on our roadmap on how we can consume SBOMs, and so it's still kind of a working process. I feel like you can deliver SBOMs in different data formats. There's Cyclone DX, there's SPDX, there's different kind of formats that we're seeing in DoD that are delivering those SBOM artifacts. So I mentioned, the DoD DevSecOps reference design, you can Google this. This is kind of just the data flow that it goes through. The CNAP is the Cloud Native Access Point. Again, within the CNAP, it uses a bunch of different tools, Istio, Envoy. It uses all the monitoring tools. It uses HA proxy for high availability. And then you go through Iron Bank, which is where you grab your hardened container images, your base images, and your platform tooling images. Big Bang is the DevSecOps platform that I had mentioned before, and that is your kind of infrastructure as code, configuration as code, where you can declaratively deploy your whole platform in a Helm chart. So it's deployed via Helm chart. The Big Bang platform is, and this is all open source, by the way. And then kind of going through the pipeline here, it goes into its ATO staging environment and certificate of field app, and it goes into these different classification levels for the DoD for cloud. So IL2, IL4, IL5, those are different impact levels within the DoD for cloud. IL2, think of that if you're familiar with NIPRNet, that's kind of your NIPR. IL4 is kind of like a lower level SIPR. Just difference between physical separation of networking, storage, and compute. And then IL5 is more SIPR, and then there's an impact level 6 as well, which is secret cloud or JWICs, if you're familiar with kind of the DoD classified networking scheme. So this is kind of the data flow for Big Bang platform. And as a system security manager, because I'm talking in regards to a system security manager, because that's who we are, we typically want to capture everything that's contained in the platform, right? In order to effectively provide assurance to the stack. So you can kind of see how the user logs into the Big Bang platform. You have the ingress load balancer. It goes through Flux and Argo CD, which is declaratively deploying your Big Bang application into whatever cloud environment, whether AWS or Azure. And then you kind of see the example YAML files, how these are deployed, how the monitoring tools are monitoring the Kubernetes clusters, OPA, validating the mutating admission webhook for any policies that are enforced on roles for production or any of the other environments. Twist lock is heavily used within the platform as their main container scanning mechanism. And so this is just kind of high level of the Big Bang platform. This is their core stack. Again, you can find this, it's open source, but this is kind of their core stack. Argo, Flux, Istio, Envoy, OPA, Twistlock, and then all the monitoring tools. So, but all this is driven by Platform One, which was created by the Air Force, and they've created all these different software factories and then all these different services. Sorry, it's like I lost network connection. Is there a specific Wi-Fi in this room, or? Not really, but. Okay. Okay. All right, so OSScow, Open Security Controls Assessment Language. So this was developed by NIST and General Services Administration. And we have also have been a contributor to this as well. It's not OPA, this is compliance as code. And so you can deploy this in an XML, YAML, or JSON format. And we have worked with the Air Force with our cooperative R&D agreement that we have with the 16th Air Force, which is Air Force Cyber. We helped build their Big Bang OSScow component definition models. And there's different definition models. There's the system security plan model, there's the plan of action milestones model, there's a profile model. But for us, we enjoy the component definition model because it's purposely built so that we can build component definitions for, the Big Bang components that you just saw. But it's not just for federal space. We can really use this in the private sector as well, for PCI, for HIPAA. So we've done this for those kind of clients as well. And then I'll show this during the demonstration as well. This is we maintain the DISA Kubernetes STIG checklist within the platform. I provided some links. All this you can Google. The NSA has their own hardening guide. I provided the link to Iron Bank. Their GitLab repo is open source. And then again, Big Bang, their GitLab repo. And then the Container Security Requirements Guides, which was developed by DISA, Defense Information Systems Agency. We have this baked into the platform as well, and I'll show that during the demonstration on how we automate the Container Security Requirements Guides. I know Armo's here. They have automated scanning tools, so we've kind of worked with them on potentially automating the entire process of scanning, remediation, and applying control statements for any distribution of Kubernetes. And so I think the DoD, they're using Convoy and Rancher for their Kubernetes distributions, but really this can apply to any distribution. Okay, So getting into the aggregation techniques. And so typically when you have a ton of components, like Big Bang, they have a ton of components, or any modernized tech stack, you have a ton of components, right? So in order to save time and money, we want to, we want to break down the application so that we can, you see Big Bang, Ignite app, mission app module. So all these things, it's not currently being done regarding attestation or assurance from a compliance standpoint. There's SBOMs and things like that, but from a true compliance standpoint, no one's really doing this. It's managing spreadsheets. And so we're looking with OSScow, hopefully to make a runtime-based SSP, and then also making it reusable so that you can declaratively deploy your compliance as code within your stack, right? It should go within your GitLab CI YAML file or your GitHub Actions templates. So that's the goal. We want to be able to automate control statements, make it reusable, so these platform teams or modernized businesses are not using spreadsheets anymore. And then also, making it reusable, it doesn't really matter what environment it's going into. You can write a definition for a certain component, and it doesn't really matter where it's getting deployed to. It could be AWS, could be GCP, it could be Azure, it could be a secret cloud environment. And so that's what it's very important. And it's also very important because we're trying to bridge the gap between compliance individuals and DevOps personnel. So how the developer can get us, the exact accurate data of what's in the application, that gives us a starting point for building a system security plan, which is kind of a main artifact for a ATO or an authority to operate package within the DoD or any compliance initiative. And so this is our initial process for component aggregation within the platform. You can see it's kind of a loose process. First, we want to really understand the workload, the scope, the controls, and the type of component. And so that's when those conversations that we have with the engineers or the developers is very important, so that we have a understanding of what we're looking to build. And then we get into the collect phase. We're really looking for, the amount of components that we have. Could be a Keycloak container, could be an Istio operator, could be an Ignite app, could be a Flux container, could be whatever, right? And we also want to look at interconnections. If there's any system interconnections that's connecting externally to production, we want to capture that as well, kind of from the data flow diagram that I showed before. How is the Big Bang platform interacting with other external entities? And then once we build, collect, then we start aggregating language and control ID and things like that. And half of Ignite, we're actually a language shop. We use a lot of NLP in the background. And so we've been doing a lot of this work the last 11, 12 years of just using NLP. You guys see ChatGPT all over the place. That's the goal, right? We would like to create reusable control statements for each modernized tech stack. And so really control harmonization, the language, and the scope is very important for us, so that when it comes time to build that initial SSP, we have all that data already, and we can just push from the aggregated form to the initial SSP. And so this is kind of our initial process. This will make more sense once we're in the platform. Oh, that's time. Okay, so let me go over to the platform. Okay. And so with our platform, we can do many different things. As you can see, we have compliance, we have pipeline issues, we have SCAP. But first, I mentioned all these things are managed within spreadsheets, right? And so first, we really want to understand the workload. And so if a component is going through NIST 800-171, for example, we want to look at that workload, right? And if another one is going through HIPAA, we want to look and see what that workload looks like. So the bigger the workload, the bigger the scope of the project or the system or application, right? And you can do this for CMMC, which is another kind of emerging compliance framework within the DoD. And then I mentioned container SRGs as well. So, but going back to our process, the loose process I was showing. So this is kind of how we visualize the whole kind of component aggregation. We build the components, right? You see, I have about 4 or 5 different container analytics is what we call it. So we have our container analytics along with our aggregation going on in the background. And so that's kind of really helped us streamline this along with the NLP and things. So, but once we can move these around as well at different stages, but we dig into the requirements and we can drill into each statement, really understanding the workload, right? And I mentioned the automated statements. We have these baked in there already. And then if there's anything customized that the client wants, whether it's testing procedures or framework mapping or any type of assets they want to tie to, we can add that as a separate tab. And then once we go through these aggregated states, I'll go through one of the container analytics for a second. So this specific container goes through, I mentioned the container security requirements guides that were developed by Defense Information Systems Agency, DISA. And so these come right straight from the regulation. You can also put tags in if it's missing a POAM. A POAM is a plan of action and milestones. We call it a deficiency or a missing URI. So the platform's completely customizable. And then we drill into the requirement. And then you can see we have macro automated statements in here where the key cloak EKS cluster is configured to use TLS. And you can see there's about 173 requirements in this container security requirements guides. And then, once we're done, you can see the percentage complete for each stage. Once we go through the collecting phase and we go into the aggregated state, you can start to see automated statements again built into this. Again, tagging, we know Istio Envoy provides some access enforcement, information flow enforcement, and things like that. So OPA for access control policy. But again, we'll drill into the actual control statement. And again, this comes from NIST 800-53. And so this we can edit in real time. These are, we call them organizational defined parameters, ODPs. These are built right into the NIST test cases, NIST 800-53 alpha. These are the test cases, and so these are already pre-built into here, and you can define your organization-defined parameter in here, right? Again, we can create test cases and things like that. If the client requested, and again, this all comes from NIST. And then once we get through the aggregated state, we go through the initial SSP, and this is what we can spit out in whatever Word document or whatever the request is from the client. So. And again, see, we can carry over the tagging, we can carry over the statements, And this is really what true compliance automation is. This isn't a checkbox item, okay? So we're building this declaratively into your CI/CD, the OSScow statements, for example. So you give us your stack, right? Whether that's a Docker Compose or a Helm chart, and then we put it in the platform, and we can break down your components by each stage, as you saw, and then we can aggregate it, and then kind of help build that initial SSP. So those are the kind of the controls, the requirements. I'm not going to go through the controls because, everyone here will fall asleep. So, but another thing that we have is the security content automation protocol. Everyone's aware of STIGs, hardening, things like that. So the Navy has the security content automation protocol. It's the automated STIG scanner, and Navy Information Warfare Center, NIWC, has it. DISA isn't funding it anymore. It's all over Reddit. You can look it up. Anyways, Ignite, we've been negotiating the license agreement with the Navy the past 2 years. And so we will be licensing the SCAP. And so you can see we have the Ubuntu STIG here, and it's mapped to our compliance. You can see it's mapped to all the different components, all the different the SSP and things like that. And so you can see we can link technical scans and link it to specific components. And then we have, I mentioned Iron Bank. So this is Iron Bank, the container hardening repo. And this is kind of where the DoD is getting their container images. And so they have a whole catalog on here. And eventually with our CRADA agreement, we'll be programmatically bringing these into the platform as well. And so again, this is Iron Bank. You can Google this. I believe their GitLab repo is open source. And then this is kind of their API for the vulnerability assessment tracker for Iron Bank. You can see the Istio operator. And then, we can go through this whole JSON file, right? It goes through the vulnerabilities, it's non-compliant. And so how we illustrate that, we can programmatically bring this in through JSON, through a JSON API. And we can illustrate that in pipeline issues. And so you can see it explicitly defines false positives, and things like that. So this is another thing that we're working on with the Air Force, is programmatically bringing in container vulnerabilities from Iron Bank and mapping it to compliance, kind of like you saw with the SCAP tool. So that's kind of that's our basic demonstration of the platform. Open security controls framework, the scorecard here, this is kind of what we use to score containers. You can look this up in Iron Bank. They have it built in when they're running their compliance scans against their pipelines. And so this is kind of built in as a metric, rated from 0 to 10. And so this is what Iron Bank uses behind the scenes. And I think they also use Anchor to produce SBOMs, Anchor SIF to produce SBOMs and things like that. Okay. So some future initiatives. We love to collaborate with other teams that are interested in this work. So, we've done a lot of work before. I mentioned, we've been around for about 12 years. We didn't initially come from a compliance background. We came, we did TPM module development for Dell. That was like our first project. So we do a lot of things that are outside of our scope, but compliance and GRC, our integrated risk management is kind of, this is our vision for the platform. So And then optimizing FedRAMP small business assurance cases. We really look at container component analytics for the future of FedRAMP because Istio, Keycloak, Envoy, all these different containers, they're not going through what I just showed you, like going through the NIST controls. It's not going through that granular IA work. And so I think that's going to be the future of FedRAMP compliance. I mentioned our CRADA with the 16th Air Force and the SCAP component development. You saw that in action. And then we're also opening, we're going to open up the API. This is our API right now. Oh, sorry, did you want to take a picture? Yeah. Yeah, so this is our API right here. We haven't fully released every microservice or every module yet. This is still kind of in the works, barring our CRADA agreement with the Air Force. But this is our API, and this is our GitHub as well. So if you're interested in collaborating, if you're a GRC nerd or developer that wants to collaborate, we will welcome you with open arms. Because honestly, there's not a lot of work being done in this field regarding component analytics and assurance at the container level. So just summarize, I know it was a quick presentation, just giving you a high level overview, the context of the DoD, how terrible the process is, and then how the DoD is currently modernizing, trying to modernize in certain areas. The Air Force is kind of driving this effort. If anyone has any questions on how to onboard Platform One or how to use Ignite, feel free to reach out to us. We automate this stuff all the time for any regulation. Actually, I think I have, we have a plethora of frameworks. I know I showed you the component mapping or the framework mapping, but you can see we have every regulation you can think of. And this is really important, especially for organizations that have to comply with different regulations. So not just DoD, this can be private sector as well. So, but that's kind of our just a high-level overview of Ignite and how we are driving and streamlining accreditation within the DoD. So any questions? We have about 5 minutes. Yes, sir. Yes.
So our company is helping the Air Force with ATO and continuous ATF as well.
Yes.
Are you involved in that as well?
Yep. So we've done a lot of projects with the Navy. They had a couple of special projects regarding NNPI data. And so we worked with some software factories within the Navy, and we worked with some software factories within SpaceX as well. So yeah, we and in the Air Force, but so yeah, it's just, it's a lot of development work right now. The OSScow being one of them, developing the component, and so I have a export of the SSP here in YAML format, right here. And so this is kind of an export that we can provide. You can see it gets into the controls, IA2, Istio request authentication, right? And so this is what we're able to kind of produce at a granular IA level. This is what we produce for SpaceX and things like that. So,
yeah, how do you interface with Platform One, being that they seem like they're leading the effort in all this?
Yeah, so it's a process. First, you got to get your containers approved to operate within Impact Level 2 for Iron Bank, which is NIPR. Once you're onboarded, your containers are hardened, and they're approved to operate within Impact Level 2, then you go to Impact Level 4. So these are different pipelines, different authorization paths. But yeah, our containers are authorized to operate within Impact Level 2 Iron Bank. So. Okay. Thank you, everyone.